And usually with a bullet equation, you know you're going to be using inelastic because that bullet's usually going to stick into what it hits, and they're both going to go together. So it's going to be an M1 plus V, an M1 plus M1 times VF type situation. Okay, so here a 10-gram bullet with velocity of 1,000 meters per second strikes a 100-gram block of wood initially at rest. What's their combined velocity? We know what that is already. I just told you basically, but I'll show you. And can you work the problem using conservation of momentum? Yeah, you have to. And then energy, we'll take a look. Okay, so momentum, we know it's M1 V1 is equal to M1 plus M2 VF. So VF is equal to M1 V1 over M1 plus M2, which is equal to 10 grams times 1,000 meters per second over 10 grams, which is going to be equal to 90.9 meters per second. Okay? So that's your velocity there. You can't use energy because it's not, this is an inelastic collision, inelastic, in-E, no energy. Okay, so if you did, you'd find that the amount of joules or the amount of energy that's used, M1 V1 squared, is not equal to 1/2 M1 plus M2 VF squared. Those two quantities are not going to be equal. In fact, if you plug it in, you'll find that this one is 5,000 joules. Okay, it's the amount of energy, and this is only 455 joules. Okay, and those are not equal to each other. That means 45 joules are used in other forms, usually heat. They go on to tell you in the study guide that the specific heat of wood is 1,700 joules per kilogram degrees Celsius. So, it basically just was, it does a little bit of thermal talk here. It shows that the temperature of the wood would actually go up 24 degrees Celsius. So yeah, you do not use energy, but you do use momentum. But anytime you think of a bullet hitting something or an arrow hitting something that sticks into it, that's where you have an M1 plus M2 times their combined velocity going up. And that's basically is a kind of a giveaway on that one. Okay, next. All right, what is momentum and how does it relate to Newton's second law? Okay, I told you earlier that we would, when we did that spaceship problem with the thrusters, that we would we'd have a problem that kind of shows where that momentum comes from. So the second law, what do we know? We already talked about the second law. It's F equals ma, and we know momentum is P is equal to mv, right? Momentum is equal to mass times velocity. Well, we know that F is equal to ma, which is equal to mass. What is acceleration? It's the derivative of what? Velocity. Okay, so that's dv dt. Okay? Well, if P is equal to mv, then the derivative of momentum, dp dt, is equal to m times the derivative of velocity, dt. Okay? Well, what's that equal to? These two are equal. Alright? So the derivative of momentum is the force. Okay? So that's just kind of a cool little proof there. Derivative of momentum is equal to force. So how are they related? The derivative of momentum is equal to force. And you can show that by breaking up it into what you know acceleration is. You know acceleration is dv dt. If you just take the derivative of momentum with respect to time, derivative of momentum is equal to m dv dt. These two are equal, so these two are equal. That's how they're related. Okay, next. Here's another one. Y direction information. What is the max altitude reached? You have a ball with a weight, a velocity. Weight is equal to 100 pounds. And velocity is equal to 100 feet per second. Okay? So we know, since we're dealing with y is equal to y0, which is going to be 0, plus v0 y t. Since gravity's going down, we'll use it here, minus 1/2 gt squared. Okay, so y0 is equal to 0, and v0, here we know is 100 feet per second. So to find the max height, you basically use your differentials. You differentiate and set y prime equal to 0. So y prime is equal to v0y minus gt. Let's take the derivative, okay? We know that's 0 anyway. So t is equal to v0y over g, okay? Which is equal to 100 feet per second all over 32.2 feet per second squared, so 3.106 seconds. So y is equal to 0 is equal to 100 times 3.106 minus 1 half 32.2 feet per second squared times 3.106 squared is equal to 155.3 feet. Okay, so that's your max height. Just remember, you got to differentiate to get your max min, and that's how you're going to get it there. Okay, almost done, guys. And then after reviewing all this stuff, you pretty much want to make your own flashcards like this, like I said, and flip through each one of those, go through them 100 times, practice them to get ready for your interviews. Okay? Here, it's pretty simple. A mass is dropped from a height h. What is the velocity of mass just before it hits the ground? Well, in this case, the potential energy is going to be nearly almost total kinetic energy. So mgh, potential energy, is going to be equal to 1/2 mv squared. So what's that velocity? Square root of 2gh. Okay? If the potential energy before you drop it, there's a lot of potential energy here. As it almost hits the ground, it's almost 100% kinetic energy right there. That's how you get it. Sweet, that was easy. Okay, next. Consider the following pendulum system. Okay? A, if a bob is released from rest, what is its max velocity? Well, we just did that. Okay, so that's mgh is equal to 1/2 mv max squared, which implies v max is equal to square root of 2gh. Okay? Alright. The second system, what assumptions are made? Well, you assume that there's no external, non-conservative forces act on the system. And then the string is weightless and inextensible. Okay? 3, what if it's in a vacuum? Well, air resistance is going to be gone. In this case, it's negligible. Okay? D, suppose the second mass is at its lowest point, what would the velocity of both masses be? Well, that's going to be, you do elastic and inelastic, so I think D is elastic, so basically you're just going to use the formulas we already had. We've already gone over those. You know, you can derive these with those formulas, your mass, your elastic and inelastic. For elastic, you're going to use energy and momentum. Okay, and if it's not elastic, you just know that your v prime is going to be equal to square root of 2gh. We've done these in former problems already, so I'm just going to show you that's what this question basically is asking you. Okay? So that's it. 2 more questions left, folks, and we are almost done. All right? Given a spring with force displacement relationship, F is equal to e to the x, determine energy required to move the block 3 units. Sounds like a differential equation to me. Okay. I'll probably just need to integrate. Okay, so here we know that work is equal to force dotted with the distance. Okay, so work is also equal to, cool part about that is that's like the area. And what's a calculus function that you can use to get area under a curve? Integral. Okay, so this here, work is going to be equal to the integral of force times infinitesimal dx's. Okay, so this is just from 0 to 3. E to the x, they already gave us what that is, what f is. Dx, e to the x is indestructible, so it's e to the 3 minus e to 0, and that's equal to e to the 3. Anything to the 0 is 1 minus 1. Okay, so that is the force displacement relationship, and that's the energy. It's the work required. Okay? Finally, last question is,